Right. Okay, so having just waffled a bit about all the problems, let's have a think about some solutions, or at least approaches to getting a grasp on our problems. So, first of all, who are our users? Considering our users, then considering the design, the interface design how we design our interface to deliver the functionality to our users. Okay, one of the standard ways of getting to understand users is to draw up some use case diagrams, and these are as simple as they look. They're just simply a diagram or a set of diagrams that show the users how users might interact with a system. These are, I hope you recognize these as UML diagrams. I'm going to show you Universal Modeling Language diagrams, but they don't have to be drawn in UML. So there's a variety of different types of these diagrams. This one is what's called a user functions diagram, which basically identifies some different users and the functionality that those different users might need. So here we've got doesn't matter what it's a system with involving administrators, people who log on to the system, users of the system. And we've also got two types of user. We've got a registered user and an anonymous user. So we've got three different types of user of this system. We've got an administrator who can log on to the system. They can log out again of the system. They can remove a user, remove a group, or remove an event, whatever an event happens to be. So they can remove things from the system, so they can delete stuff from the system. A registered user, this is a sort of social networking system by the look of it, as I read the list of things that these users can do. So a registered user can log in, and once they've logged in, they can add friends, create groups, create events, edit profiles, whatever, edit their profile picture, log out, post to their wall, so it sounds like something like Facebook or LinkedIn or something like that, create groups, remove people from groups, etc., send messages. So there's a whole list of things that registered users can do, and an anonymous user can register and then become a registered user, but they can also have some limited profile information on the users. Not quite sure why recover password is out there on the own. It's because I suppose anybody could recover a password. It's not integrally linked to a user. Even an anonymous user could try to recover a password, but presumably they don't have a password, so it would fail. But they can still access that. So that's just a very simple diagram showing you the various, listing the user functions for the different users. Often these can be more expansive, so these are very simple, they're written like method names, but you can also write them in more human-centric language. And it's also, well, same as the other diagram, we've got several users here, and the diagram actually sort of differentiates between different users in having access to different parts or components of the system itself. So this is some health system where you've got some people inside and some people outside of the firewall. So I think this is inside the firewall and this is outside the firewall. So we've got, in this case, we've got providers of information, people who query results, reviewers of information, and then we've got people requesting information. And in this case, rather than giving sort of command method, short method names, we've actually used English, sort of plain English to identify what the users are going to do. So clearly if you're trying to show this to a senior manager or to present the information for what your various users and what they can do to a senior manager, it might be more sensible to present it in this way than using the sort of method names and things like that. These can be more complicated, and you can actually see connections where there are connections between users and what users do. You can put linkages into your diagrams to show the procedural connections between what things do. Okay, this isn't a computer program, this is a restaurant, but it doesn't matter. So we have our client. Our client orders food, which involves interaction with the waiter. They might want to extend their order to include the wine menu. Once the order is confirmed, sent to the chef, etc. So it's not just showing individual users, it's showing how the users interact with one another and messages get sent through the system. Okay, so that's basically use case diagrams are a great way to get a feeling for what your various users are and how their uses vary. Now you've got an idea of who your users are, you can start focusing on individual users and how they individually may use a system. And one of the common ways this is done is by the process of storyboarding, which is pretty much exactly what you would do if you were writing a movie, for example. You would storyboard the scenes in a movie or an animation or anything like that. It's exactly the same principle. These are generally done as graphical cartoons, effectively, descriptions of a person's interaction with a system with a particular emphasis on the user needs over the business requirements. So if we go back here, this is sort of emphasized, this is interested in the users, but it's also looking at the business side of things, what these users are actually, how we, to a certain extent, how we share these functions between different groups of users. So it involves the internality of the system as well to a certain degree. User storyboarding very much focuses on the user's experience of a system rather than what the system needs to do to deliver that to the user. So this is very human side of it. So here's a very simple example for an ATM machine. We've got a description, a text description here. Somebody wants to fly to Sydney, doesn't have enough money, etc., etc. A little story about an individual and what their usage of the system is going to be. This is a different, so one can write it out in English like that. One can have a use case or a storyboard effectively in text, just written as a sort of text description. But it's probably more common to draw up a sort of storyboard, a little graphic cartoon to explain what's going on. Now, what's going on in this one? I have no idea what's going on. This story depicts somebody's asleep, they have an idea, what do? They enter it into their laptop or their phone. Let's do lunch after class. Doesn't really matter, but it tells the story of somebody using the system. I should have paid more attention to that earlier today and had a look at that. Okay, these storyboard elements. So Turong et al., 2006, had a look at storyboards, and they got both professional people who draw storyboards as part of their working life, and they got some novices, probably students, almost certainly students, to draw storyboards as well, and they compared them and they evaluated how good the various storyboards were created by novices versus experts to try and sort of optimize storyboard building. The creation of storyboards, they looked at 5 things: level of detail, inclusion of text, people and motions, number of frames, time, whether to explicitly include time to come up with some guidelines. Basically, their study identified that generally less is better than more in diagrams, so the level of detail. So here's 2 storyboards for exactly the same event. scenario. One includes, you can see a lot more detail, windows, things on the cooker, etc., etc. Another one is much more of a sort of car, very stick man, stick woman in this case, stick woman and stick baby, very much minimalistic. And these were deemed to be more useful than the ones with the extraneous information, not surprisingly. These were more understandable, more immediately understandable, basically. So keep things simple in your storyboard is the lesson of that one. Text, so as I said before, you could have just a story through text, or you can have a story just through images, or you can have images and text. So they decided, well, they looked at whether adding text was helpful. Well, they did say, well, it does improve understanding. It adds, not surprisingly, if you've got a picture and a text and both are sort of telling you the same thing, as we saw with this one further back, and my inability to decipher that on the fly, that sometimes it's, if you don't have the context, some context to go with it, it can be quite difficult to understand. So certainly text can improve understanding, but they did come up with, suggest that, okay, this text can also bias how you think about the picture and what people are doing. The text can influence, if it's incorrectly written, if it's written from a particular perspective, perhaps, it may influence your understanding of the story. So it can introduce bias. Basically, the other thing is, obviously, there's repetition there. And generally, we're against repetition in life. So ultimately, it just replaces the function. So either a text user description or images, sort of cartoon. You could mix the two, but you shouldn't have to if you do a good graphic storyboard. How many panels? Again, complexity. So they identified novices tended to use a lot more panels than experts, people who did this for a living. People, they had the skills and the knowledge to condense the actions into fewer images or fewer cartoon sections. So they can create smaller concepts, fewer panels. And they deemed that 2 to 6 panels was optimum. So if you're drawing a storyboard, don't give me an entire page of cartoon. You want 2, 3, 4, 5 images or sections to your story, your used story. They also looked at time and decided that time was there was no point including time unless it had a specific issue in the usability story. So in this case, the museum shuts at 4, so it's really important that that's part of the story because there's a real cut-off point. But if it was just generic and it wasn't to do with things shutting down, then it wouldn't matter. We wouldn't include a clock just because it's a museum with a clock on the wall. People and emotions. Do we like emotions in these diagrams? Do we like people? Does this help? Well, that varied, the opinions varied. So some people like having emotions in these storybooks because it answers this question, or it provides an answer to why do I care about this thing? But it also tends to lead to a consideration of why things are used rather than how. It can add in additional stuff. We're really interested in why things are going on, how things are happening and how our system can help, not why this baby is crying. Okay, so story use cases. Good way of getting a handle on who your users are and how they might interact with your system. So for your GeoWeb application, or at least one use case is a good idea. Okay, so we've got a graph on who our users are and what they might wish to do and how they might wish to interact with the machine, what context they interact with the system. So now you actually have to get down to the nitty-gritty of building the system itself. So the usual thing for a computer-based interface, a screen-based interface, is to draw up a paper prototype or also known as wireframes. I ask you to do this, and you know, it's exactly what it says pretty much on the tin. You just hand drawn or on a computer, just draw out a little diagram that shows the various components that you're intending to have on your web page. You don't need fine detail. It's just a wireframe, a rough exploration of how you might do things. So here we've got various tabs. We're looking at some kind of page set out, print menu. We've got pull down menus for letters and widths and sizes, portrait landscape, OK buttons, cancel. And clearly we could draw out a variety of these different interfaces, show them to users, show them to managers to make comments on. Now these are great for the structural layout of a system, but there is no interaction here. So you can't point and click on here and see what happens, which is part of the usability experience or the user experience. There are, I believe, programs now that allow you to build, basically draw these wireframes and click on them and see underneath. So at least get some great experience of at least the different tabs and things like that. Clearly pressing the button, you won't know what the user experience of pressing the button is until you've programmed, actually implemented the program to do whatever you do when you press OK. So wireframes, yes, let's see some wireframes, and most of you had drawn some up. Widgets, so your wireframe diagram has these various widgets. I call them widgets. I'm never quite sure what they're called. I like widgets. Widgets, just what do I mean by a widget? It's a thing that you can manipulate on the screen, pull down menus, buttons. Sometimes they're usually just simple things like here, but they might actually be more complex widgets made from simpler widgets combined together. So here we've got, important thing about widget choice is that there's lots of different ways to do the same thing, present the same information. So in the practical, I show you about 4 different ways to search for country, each of which has its pluses and minuses, the different ways you've got to search. But which one is best? And that's what you're, as designers, interface designers, you have to consider which one is best. Again, if anybody comes across a nice list of pros and cons of various interfaces, and I'm sure there must be one out there, then do send it my direction, because I've sort of been looking for one for a while, haven't managed to turn one up yet, but probably haven't spent enough time looking for one yet. So here we want to choose multiple choice. Here's a multiple choice. So one thing we could do is provide them all in a list and allow the user to choose more than one item, check boxes, and then we press OK. Here's an alternate version for the same thing. Rather than having a checkbox embedded within a list, you're familiar with these, you can select them, you can move them over into this. This is your select box over here. We can select all, move them across, push them back if we don't want them anymore. We can also order them within here as we feel fit. These both allow us to do 2 things. It's the same thing, which is to make a multiple choice, or a multiple choice among multiple options. Which is better for any particular task? I don't know. But I suspect this kind of approach is all right when you've got a few entries, but will get very unwieldy the more and more entries there are in that list. If you're having to scroll down 100 items, that's going to be a pain. Mind you, scrolling down 100 items here is potentially also a problem. So maybe if you had a huge number of items, you'd actually preferably have a search function to allow you to subset the items in the list from the start, and then maybe move them over into a box like this. So which one of these you do, I don't know, depends on how many items you've got, how it fits onto your screen. This obviously requires more screen space than this one. If you're limited in space, maybe you're going to take that approach. If you've got lots of space, maybe you're going to take this approach. There is no hard and fast rules about them. I want you to just realise that you need to think about these issues, and they can make quite a difference to how usable a system is. Here's a statement from the Web Standards Guidelines from the HHS, which is something to do with health systems. I can't remember exactly what HHS stands for down here, but they say designers typically consider such issues such as the available real estate, as I was saying, this one takes greater real estate than this one on the screen, reducing the number of user clicks and whether the user will be choosing one from among many of items or several items at once. But one study showed that some users, particularly older users, do not know how to use a drop-down list. So you're only testing, in such cases, only testing will identify such problems. So this may seem a perfectly good solution, but your users are a particular subset who may have problems in actually knowing how to and understanding these affordances that they're given, as in there's a pull down, that means there's a pull down menu, and when you pull down the menu you make a choice, and that has implications. So that's your paper prototyping. This is all rather broad brush, as I say, prototyping. Then you need to consider which one of the options, obviously, of the different widget options you've got available you can use in a particular circumstance. Once we've built an interface, or maybe we've got alternative interfaces, how do we decide which one of those is the optimum one? Now, this is one approach to doing that, and it's called the model human processor. So this works under the principle you're basically summing up, doing a sum as to how long you think a task is going to take. So if we know if we specify an interface that allows a user to complete a task through a number of steps, so we've got an interface and a number of steps to complete things, we can estimate how long it takes to complete each step. There are figures for how quickly people make selections with mouses, how we know how long programs potentially take to return information to do the processing. So we can take all these actions, both human and the computer component of it, do a sum, add them all up, and estimate how long it takes for a task to be completed given a given interface. So we can design an interface but not actually implement all the code. We can do these sums on basis of average figures to get ourselves an estimation as to how efficient that interface is to a task. And we can then, if we have different interfaces, we can find which one is more optimal given this way of measuring things. So that includes not only the processing time of the computer, but also things like the time that it takes to process your motor functions, get your motor functions into organized, the time it takes to process the information coming in through the eye. The more information coming in, the longer it's going to take to process and to in the air. The time it takes to drag stuff out of memory, integrate it with what you're experiencing. As I say, that can take a lot of time involved in extracting stuff. And there is both two types of memory. I don't know whether you're aware of this. There is the short-term working memory, the equivalent of your RAM, which you've got pretty much quick access to, stuff that's sort of in your mind, so to speak, at the time. Then there is accessing other times. You have to access things in deep long-term memory, and that's, again, potentially a greater delay. So if you're having to dredge stuff out of your deep memory, your long-term memory, that's potentially slowing the system up. So what do you do? Well, you build up a function model about what the brain has to do to complete a task, what the physical actions to complete the task, estimations of how long the computer is going to take to undertake the tasks, put them all together and add your sum up, basically. So these sorts of general figures are the sorts of figures that people use to plug into these sort of equations sort of generated out of all these steps. Okay. All right. What else? Whenever we're built apart, so we've got the specific things to do, the specific tasks that we're undertaking and wanting the users to undertake with our particular set of users. But there's also, there are also things that are helpful to consider when creating an interface, basically general design principles. There are general design principles, then there are specific guidelines that address particular issues of design and communication of meaning. So for example, this paper here looked at various ways in which you can badge or provide degree of confidence to your website. So people visit websites, they want to know that they're in a trustworthy place. After all, we're living in a world of fake news and things like that. How do we get over to people that they are in a trustworthy place and that they are in the right place? So this was a set of guidelines through a sort of experimental usage questionnaires of how people understood sites and design elements and things like that, to come up with a set of guidelines for making your site seem authoritative for public engagement and trust, to imbue trust of the user. Then the other thing you need to consider is any organizational corporate design style standards and guidelines that might exist within the organization you're operating. There are so many lists out there of good web design and lists of bad web design. This is just one of the ones that I have to grab off. You do have a look at some of these lists. Most of them are reasonably self-evident when you think about it. The problem is not knowing these things to a certain degree, it's actually how managing to implement it yourself is probably the greatest problem, I think. So simplicity, generally one should aim for simplicity, be consistent. We've talked about the navigation being intuitive, things like that. Good impression, give a good impression when you first arrive. Don't provide an ugly scene, make it a nice experience to visit. Colours, be careful about colours. Colour is probably the most dangerous thing, I think, for many people when they're coming into design to start with. We tend to like nice bright colours as human beings, but when we may look at it and then we look at somebody else looks at it and it looks hideous. So filling the browser window, using the space is quite important as well. That's something other people don't do. You get a tiny little map here. You've got a whole page, a whole screen, use it. I mean, nowadays, so when web maps started, they were often in a little window embedded within a page. A lot of applications now, as I'm sure you're well experienced, are full screen applications, and with the widgets to a certain extent embedded within the map or sitting on top of the map rather than taking up space around the outside. Multiple browsers, okay, I'm not asking you to worry about multiple browsers in your web application. Just get it working with one browser and tell me which browser it's working with. That's all I'm really caring. You'll get extra marks if it works for lots of browsers and you say you've told me you've made the effort to do that, but it's not something that I'm expecting. Errors, anything, get 2 pairs, 3 pairs of eyes on things, spelling mistakes. Incredible how easily some simple grammatical and spelling mistakes can turn the users off or the visitors off from your website. Write your own code. Yep, okay. Basically, if you write your own code, you know exactly what you've done and you have full control over the system that you're developing. If you take other people's code and hack it, which can be a good thing, it's also dangerous because you often don't fully understand what that code does. Oh yeah, don't forget you actually have to have some content, yeah. So so this is an example of a sort of domain-specific or governmental advice. So this is HSS, which is again the US Department of Health and Human Services. This is who these people are. So they have So this is the US government health department. They have guidelines for web standards for web pages that they create. So if you're part of an organisation, like I'm part of the university, I should probably check the university. The university has a corporate kind of image, has a corporate image and a set of corporate guidelines for how, for example, logos are presented, what fonts we're meant to use, and things like that. I tend to just ignore them, but that's bad. So beware of various guidelines by employers. Okay, so we built something, maybe a prototype. We need to actually test whether it actually, how usable it is. Because of all our theory, it's all very well, and hopefully it's created us a reasonably usable system, but until we actually get users to use it and get feedback, we'll never actually know until that as to whether it's a good system or not. What do you need to test? Well, you need to test that it does what it's meant to do, that it meets its user requirements, that the user specification, the specification for the system is met. The functionality that's been delivered has actually been delivered. You can test how well it works, because performance may kill a system. If a system doesn't perform adequately, might as well throw it away. What is acceptable performance, of course, depends on what the system is meant to be doing, who the users are, what the context is, etc., etc. They can test how well the user interface design delivers the functionality. And the other thing to check is the help facilities. Are they adequate? Can the person, when somebody gets stuck, can they find out how to solve their problem, for example? I'll run through 4 different approaches really quickly, 4 different sort of methodologies that have been used for doing usability testing. I'll just run through these quite quickly. So a heuristic evaluation is basically an expert opinion evaluation on the basis of some kind of criteria. Do you know what the word heuristic means? A heuristic is an approximate approach. It's not an exact solution, it's just an approximate. It's a sort of lick your finger, stick it up in the wind approach, if you know that metaphor. So basically, you write a list of things that you say are important for the system to be usable, measures of usability. So Nielsen, 1990, provided this list. Do you understand what state the system is in at a particular time? So, for example, things like the eternal worm of waiting, whatever that's called. I'm sure it has a proper name. Does anybody know what it's called? The thing that goes round and round while you're waiting. I'm sure it must have a proper name. Anyway, so the visibility of the system state. So is it thinking and should you wait? Or can you interact with the system? That might be an example. How well does the system, what you see in the system, map onto your understanding of the real world? Or is there a conceptual kind of gulf between how the computer models the world and how you feel the world actually exists? Does the user have the adequate control and freedom to do what they need to do? Now, control and freedom is an interesting one, and I was reading a paper about this yesterday on the train. One of the ways to improve usability and efficiency of usability is to constrain what people can do with a system. So if there's a clear path to get from A to B, for a user to get from A to B, if you provide the ability for people to leave that path and to do other things, then they're going to be inefficient and the system will be used inefficiently. So providing functionality which may seem to be useful to some people may actually decrease the efficiency of the overall system. So bear that in mind. Freedom has some advantages because it allows people, you've got particular questions, maybe to go and address those questions before they carry on along their pathway, but it also may distract people from the efficient pathway that they should be following. Consistency and standards. Are you using, are buttons the same shape and colour, for example? You know, is there that's consistency? Are you following, does a button look like a button? You can throw rotten tomatoes at my buttons in a minute. Error prevention, so recognition over recall. So you should be able to look at the screen and know what you can do, not have to think, what should I be doing now? Okay, so it should be immediately apparent from the screen in front of you as to what you can do. Aesthetics, minimalist design, yep. Let's try and keep things generally there is a belief in information design that minimalism is a good idea. And I think in general it's a good idea. I do agree with that. But it can get a bit boring sometimes, too much minimalism as well. Help and documentation. So basically a checklist of things, go through them, expert looks, says how well they match. Alternative approach, Lewis and Wharton, 1997, a cognitive walkthrough. So in this case, you go to your cabinet of hats and you decide that you're an old lady from Burnley or something like that who's got a task to do, or you're a school kid or you're a whatever. You take on try and take on the personality and the persona of one of your users, specific users with a particular user background. And then you identify a task, choose some sort of task, you specify the correct action sequences for the task, make sure the interface states, determine the interface states along with the sequence, and then you try and follow the path. Well, for each action, you then construct a story that explains why a user would choose that path, or a story which explains why they wouldn't. So you basically try and mentally think your way through the system and say, how would this person potentially use this system, and would they end up following the right path if they made those decisions, being who they are? And then that allows you to identify problems and reasons why somebody might be not following the optimum pathway, and that allows you to consider redesigning the alternatives. So this is basically, to me, well, no, they're similar, but they're not quite the same. This is a checklist, tick checklist. This is, can you pathways through the system? A pluralistic walkthrough is basically doing walkthroughs, but with a focus group of developers, users, and specialists in the area. With a facilitator, you basically spend your time doing tasks, looking at the interface, talking about how easy it is to use, how it could be improved, etc., etc. Sort of focus group type of approach on interface consideration. The final one that we've got here is a structured interview and observation approach, where you identify, query the users, identify what their background is, bring users in, try and understand their world view on the system, and then you run them through specific tasks to see how well they do them and how well whether they interpret the output correctly. So here's an example of the sorts of structured interview questions that might be involved in a structured interview. So have you had any formal training in geographical information systems? How would you rate your level of experience in computer maps? Are you familiar with the index of multiple deprivation? So some questions on what their experiences are. This is to do with a health application. So then we've got a section here on sort of what they call their worldview and preferences. So in this case, what colours do you associate with health and disease? So you're designing a mapping interface that's showing disease versus health. Well, what is the natural, what do people think of? What are the colours of disease versus the colours of health? Greens and purples and yellows for disease and, sorry? You think white? Right. Yeah, there's that sort of sterility. White's difficult because it's mostly your background's white. Blue is often used for health. Think how many companies and logos are blue. It's a very comforting. And green as well is could potentially be health, but would be plants rather than animals perhaps. But yeah, so there may be natural colours that people associate with certain things. And then we've got another thing here where they show 6 maps and they ask for their preference for the colour scheming on the map. So, and then performance, how well do people read graphs? How well do people select and understand the information that's presented to them? This diagram, there's where you can see it in full-on net. So I've just talked to you about a very few of the possible user design tools and approaches and evaluation approaches. This diagram is quite good. I like these diagrams. I'm a big diagram fan, as you know. But this sort of diagram shows a whole list. They're unreadable from where I am, never mind where you are. But we can see that there are different tools that come from different disciplines. So we've got some which are particularly technologically orientated, human-computer interaction for being one. Some which come from the design side of things, do with design thinking, design, service design. I really don't know much about these at all, or anything about most of those. From the business side regarding marketing and research, and also those from the social sciences. And this is quite a nice diagram because it has the various tools and where they've come from and when they were invented and a little bit of text on them. So I quite like that diagram. I'd advise you to have a look at it. Okay, so that's all so good. That's what the theory is, etc., etc. But what is the reality? So Nidavala et al. Surveyed 7 Finnish mapping companies and found only patchy formal use of usability analysis methods. And that these were not particularly not used, usability methods, formal methods were not used when the developers had a good understanding, thought they had a good understanding of the problem. So the reality was that many companies, seemingly, not in Finland anyway, weren't actually using these approaches which have been developed in academia and elsewhere. They did use them, though, when the application had many users. So the more users there were, the more chance that they used a formal usability approaches, especially with internet applications where potentially your user base is much larger. They used them more on mobile devices, I think because of the constraint, almost certainly the constraints imposed by a mobile device, small screen area, using outside, using while walking along. It's a challenging user environment. And for Finland, in unusual circumstances, so outside in midwinter is a usability problem, I should imagine, at minus 35 degrees, and you can't take your 3 pairs of gloves off to press the screen. Yeah, so that's quite understandable. But the review did identify that these companies are starting to use these approaches, and that why they're really using them is that the customers report that they get a better product at the end of the day. So there is sort of starting to be some evidence that these are actually practically beneficial to the system design. Just to finish off, really, okay, I was meant to give you round 2 of the sort of tale of 2 databases. I can't say I've got time to do it, but never mind. Here's a little bit on, remember the Entangled Bank? I'll remind you. So it was a database that I built with a web interface for Imperial College, linking a whole load of mammal data sets. It was a bit of a flop. I think the system I built was quite good. It did what it was asked to do, but there was a real problem in who the users were. We didn't really consider closely who the users were. We just thought we knew it could be any scientist, and you waved your hands and that was it. There wasn't any clear thought about how people might use it, particularly. So, and the ended up, the system, it still runs on an Imperial College server, but we don't know how many people access it because we haven't any time to write any code to store the number of users. So it's kind of died as a system. Anyway, so when I was pitching it, so after 2 years of working away, we had to go apply for some more money. So we had to make a pitch for what this system was going to be. Our pitch was basically, this was our sort of use case. It's not a classic use case by any means, but it's an attempt to sort of write sort of pseudo SQL that says what the kind of system, what a person might use it to do. So they might ask for a return, send it to me, get the data, for a set of time series as a CSV format, comma separated values format, a set of trait information, this is things like how big an animal is, how many offspring it has, as a CSV file, a table, perhaps range maps in KML format, but maybe some other format, GML, maybe shape files, maybe mapinfo format, any particular formats. We may want a subtree. So remember, a phylogeny is an evolutionary tree. So we might only want a part of that evolutionary tree extracted. So maybe we want a least common, a subtree of the full evolutionary tree as a particular format of a tree format called Newick, a Newick string. And we might have some where criteria where a taxon are rodents, so rodents that are greater than 35 grams and whose range overlaps a spatial bounding box. And there are time series for these organisms between 1900 and 2000. That was the kind of query we wanted users to be able to implement through the interface. And that was basically our kind of example of a use case. I drew up a wireframe diagram for the interface. This is before I'd ever built an interface in my life. So the general idea, we've got a set of different data resources. These data resources are either ranges, so some kind of polygon representing some kind of spatial range, and polygons in this case. We've got a tree symbol representing trees, and we've got a sort of table, something representing a table for tabular data. So we're integrating, we're querying across geography, trees, and traits in this case. Maybe we can add more sources or remove sources if we've decided we're not interested in sources. We can then implement a number of queries onto those data sets, and those queries may involve a query across a tree, a query within a table, or a geographic query, and we can chain those queries together. We can perhaps turn them on and off, individual ones, to see how which components of the queries affect the results. We've got some kind of summary of the results down here, how many taxa we've got data for, but those taxa, not all the species, are in all the sources or in all the queries that we've added up together. So we may want some information about which species match the geographic query, which ones match the table query, etc., etc. We then want a set of outputs. Remember this list of different data types that we might want to return, so we could add a new output. Maybe we want to return a tree in a Newick format, maybe we want a CSV file, maybe we want to return some shape files. So we have a sort of list, a basket that we add to for outputs. Press the get button to return all that data, zip it up into a zip file return to you. Now, depending on one of these queries, when we select a query, this part of the window changes to display the query, the interface that allows us to build that query. That query could involve one or more of the source data sets that we have selected. Not all source data sets have to be in all queries. Okay. We can give the query a name. These queries are being chained together one after the other, so we need some kind of and or function to chain these queries together. Interesting. This is the map interface. We can draw polygons, lines, points. It's done in open layers, so we can draw a polygon and select, the geography within the polygon. We can change the base maps. We can add a bounding box query. We could even upload, in theory, upload a shapefile for a shapefile-based query. So that was the idea. The reality turned out to be somewhat different. This is the main web page. Now, I think I've been a bit over the top on my Gothic design. I sort of got a Gothic metaphor in my head with sort of old Victorian animal collections and things like that, and I sort of went with that because rather than sort of your normal everyday buttons. Whether that was a good idea or not, I don't know, but it certainly made it look different. And I think one of the things that we haven't mentioned so far is just novelness. And I think novelness can be quite positive. So this is what I ended up with. So rather than everything on one page like this, I ended up with a whole load of different pages which were connected together just because that was easier to build. So you can click on these. So to create a new names-based query, you click on here and add a name-based query, here to add a tree query, here to add an attribute query, here to add a geographic query and a time query. These all open different windows in which you can undertake those queries. I'll show you them in a minute. Whenever we add a query together, once we've done a query, we get a list of how many sources we're querying, how many species names match the chain of queries that we've put in, and how many species are in each of the data sets that we are querying on. And this is the chain of queries. There's a geographic query, so we're unioning the result of a tree query and a geographic query together, and we can just press the X to get rid of our query line. Down the bottom, we've got the outputs. You can select which data set you want to get an output for. You can add it to your output list. Okay, right, we're dying. We can add it to the output list, and then when we're ready, we press the basket, we return a zip file. This is the rather ugly form-based interface for searching for names. When I was looking for this morning, I thought, I haven't looked at this properly for about 3 years, and I actually have trouble understanding what I was doing myself at the time, and I've just run out of battery power. It said 70%, and it's 7%, and it just died on me. Ah! Well, I don't have a power cable with me, so we're gutted. All right. Is this on? It's end time anyway. Basically, I was going to show you a couple more of them. There's one more slide that summarizes things at the end. Have a look at those. Yeah. So the reality, as you can say, is that there was quite a difference between what I thought I would like to make and the reality of what I did make within the constraints. And to a certain extent, your GeoWeb